Thanks for joining me and my little Tangerine Tiger here tonight. It's a bit cold in this workshop, but the things I do for the love of education. Well, I'm starting a little bit early this year. I've got my Christmas mug out, trying to get a bit of Christmas spirit going. I mean, it's been a funny old year. Whichever part of the world you're in, I'm sure that you've been suffering a little bit, whether it's through a pandemic or whether it's through politics. I'm sure we all suffer the same problems. So my heartfelt sympathies go out to all of you. Last time we tackled what I call the flaky part of grayscale engraving. You would think that grayscale engraving and grayscale photographs would go together and make a perfect marriage. I think we demonstrated that it was rather difficult and probably not a very good, stable process. Today we're going to tackle the more credible part of grayscale engraving, and that is 3D engraving. In the same way that grayscale photo engraving could only be done on certain materials, there had to be materials that would scorch, grayscale 3D engraving can only be done on certain materials, and it won't be the same group of materials. For instance, we can't 3D engrave a piece of card or paper. It has to be a piece of wood with some thickness on it, for example. Leather, I've never tried to engrave leather, but I suppose it's possible, but I'm sure it would be very difficult and charcoaly by the time you've finished. Plastics, materials like corian, for example, which are basically a powder-filled acrylic material. You'll be able to engrave acrylic. All sorts of woods like MDF will engrave. Plywood, ordinary wood, many ordinary woods, but one of the problems with many ordinary woods is the huge change in the material texture as you go within the wood itself, because you've got resin, you've got hard parts, you've got soft parts, depending on the growth rings that take place in the wood. The molecular makeup of the wood changes, and so consequently it's very difficult to get nice uniform engraving with some woods. Now I've put my little test pattern back into Photoshop and I've converted it into a grayscale image, and then I've modified these first 5 pixels here, as you can see, such that I've got black, 3/4 black, half white, which is mid-grey, then we've got a quarter grey and something that's nearly white. So we've got a fairly reasonable quick change over those first 5 pixels. But then when we look at the signals to create the power for these, we should get an idea of what's going on. Now I anticipate that, for instance, for that pixel there, it'll be 100% on. For this pixel here, it'll be roughly 50% on, 50% off, and this one here, it'll be nearly all off. It's not just a matter of having this grayscale on here. We have to tell RDWorks that we want to use grayscale. In other words, we want to make the signals for these colours proportional to the colour. And we do that by putting this switch on here. It's called output direct. What we can do, we can choose here min power and max power. At the moment I've got it set at 1 for minimum power and 100% maximum power. Now what that means is that I'm going to use 1% to represent white, 255, and 100% to represent 0, which is black. So I'm going to burn as much as I can for black and as little as I can for white. That's fine until we look at the calibration graph for this machine. Now the tube itself it should technically be linear, but in reality it doesn't look as though the output is linear. It's not bad, it's sort of linear, but not exactly. If I was to choose 50% power here, I would get roughly 50% black and 50% white. In other words, I'd get a mid-grey. It gets a little bit more complicated than that, because below 10% we don't mark the material. So there isn't any point in going down below 10%. So what we do, we set that to 10%. And now what happens is this gradation, 256 grades of black and white, are spread over 10 to 100, not over 1 to 100. So whatever range you specify here, the grayscale 256 divisions get divided into the scale that you set here, the max and min. It gets subdivided into 256 parts. Because of the PWM, we have the choice of a frequency of anything from 0 to 25 kilohertz. As a mechanical engineer, I'm struggling a little bit to try and work out what the best combination is. We'll set that to 20 kilohertz, and we've got a speed here of 100 millimeters a second. And there we go. We're expecting to see, if you remember, 20 pulses per pixel. These are the first 5 pixels. Look, there's a black one on permanently, more or less. This one is slightly lighter and it's off for some of the time. This one is mid-grey and it's roughly 50% on, 50% off. This one is lighter, so it's off more than it's on. And this one is nearly white, so it's nearly off most of the time and just a little bit on. So if I change this frequency here to say 1, so that I get 1 pulse per pixel and not 20 pulses per pixel, 1000. And there's my first pixel. There's my second pixel. There's my third pixel, my fourth, and my fifth pixel. Here are 2 things that are exactly the same, relatively speaking. They don't look the same, but I can either choose 20 kilohertz, and here are my pixels. We can see here the black one, the dark grey one, the 50-50 mid-grey one, then the lighter grey one and the nearly white one. I mean, the nearly white one is mainly off and only just a little bit on. And here it's 50% on, 50% off. But look, I've got exactly the same situation here when I run, instead of a 20 kilohertz time base, if I run a 1 kilohertz time base. I've still got my power on per pixel. This is 50% power on and 50% power off. And this is 50% power on and 50% power off. Which of them produces the biggest burn? Let me try and put this into some sort of humorous perspective that helps me to try and analyse the amount of damage that would take place under these 2 different circumstances. If I was intent on committing suicide, I could jump out of the ground floor window 20 times. Or I could go to floor number 20 and jump out once. Now, I know it's a fairly brutal analogy, but I'm going to do a lot more damage when I jump out from the 20th floor than if I'm going to jump out 20 times from the ground floor. If I leave it set at 20 kilohertz, then this will automatically adjust itself to whatever size pixel and whatever speed I'm running, and it'll put an appropriate number of pulses in to each pixel. But it doesn't mean to say I'm getting the best amount of power out of this machine into every pixel. If I want to try and do the analysis carefully, as I've done with my spreadsheet, and calculate what the optimum frequency is to get 1 pulse per pixel as opposed to 20 pulses per pixel, I think I'm going to get a much more efficient burn out of this machine. Okay, now I've devised a very simple test. We've got a mid-grey test square, 10mm square, like this. Now, I've got a 4-inch lens in here because I know from previous experience with 3D engraving that you actually need a long focus lens. Previously I'd used a 2.5. This time I'm going to try and use a 4-inch lens. So this first test is the 20 kilohertz test. Wow, there's a lot of material being removed there. And now we do the 1 kilohertz test beside it. Just do a quick measurement, approximately 1 millimetre. No different. Colour? No different. Finish? No different. So it appears I'm worrying unnecessarily. They come out to the same result. I had the air assist on, so I was blowing the smoke back down onto the job. I'm going to turn the air assist off now and see what effect it has. So that's good, that's hardly made a mark on it at all. Look, it's pretty clean. so we're not blowing crap down onto the job. So that's the 1 kilohertz as opposed to 20 kilohertz. Let's just try the 20 kilohertz beside it this time, just to be sure that we're comparing eggs with eggs. Now I look at that and I think to myself, I've got more damage along this bottom edge here with 20 kilohertz than I have doing it the other way around. I saw it there and I thought maybe that's an exception, but no, it's repeated here as well. So the 1 kilohertz gives a cleaner engraving result. We're going to go and search on Google for 3D engraving bitmaps, and we get all these images to look at. So let's just click on some of these, just click on the images, and these are special bitmaps. You can't just take any photograph and do an engraving. You have to have a specially prepared bitmap, because these bitmaps have got a strange look to them. They look almost like wax. This is a good example of what I mean. Basically, if you could remember black is 0 and white is 255. And there are all these levels of grey in between those two numbers. So if you look at a survey map, say a mountain, there will be little rings around the top of the mountain, and the size of the rings will tell you what the shape of the mountain is. As you go further down the mountain, the rings will get bigger and they will get all sorts of funny shapes, but the line that's drawn that funny shape is at the height of the mountain. It's like a slice through the mountain. Well, that's effectively what this is. This is a 3D object that has been sliced this way, and the lines that are on top, the layers that are on top are white, and the layers that are at the back are black. And that's how we've got 3D-ness into this picture. We've used the colour as a 3D feature. So you can't just take an ordinary photograph and use it, because it doesn't have this information in it. The colour codes the third dimension. File, import, and there we go. 100? No. We were running at 100 millimeters a second and taking big chunks out. I think we'll run that at around about 200 millimeters a second. I'm just guessing these parameters. Advance, it doesn't make any difference. We'll set it to 20 kilohertz because we found that it makes no difference. And minimum power, here's the difficult bit, because I don't know at what level power we shall see nothing. So I'm going to leave it set at 5 and 100. We've got our output direct switched on, and our swing, I very much doubt whether they're going to get 0.1 with a 4-inch lens. It's probably going to be 0.2. So maybe, mind you, if I do 0.1, I shall get like a double cut. So yeah, I think we'll leave it at 0.1. The question is, what should we try and engrave? If I engrave a piece of plywood like this, then I'm going to get different layers in it. Now that might be interesting to see different layers in here, different colours. Nice and grainless, this poplar plywood. This is very soft, so it should burn quite easily. I'm just putting the magnets on here just to hold it in place. My focus should be set to 15, but what I'm going to do, I'm going to set it to 14 so that it is, we're probably going to go 2 or 3 millimeters deep. Now this is a very long focal length lens, so it's not going to make a great deal of difference to the focal distance if I change it by a millimetre. But basically I've now set my focus roughly 1 mil inside the material. This is quite a big program. There's a lot of information in here, and I've probably mentioned to you before, what I do, as soon as the head moves, I'm going to press pause, because the program is going to take quite a long time to download, and I don't like the machine to try and walk and talk at the same time. Okay, so I've turned the air assist off now because I don't want air assist on. We're just going to close the lid and let the smoke get sucked away. I've just remembered, we did say that 1 kilohertz was better, because 1 kilohertz actually gave a cleaner result. So we're now going to close the lid, getting a very, very deep cut. I think it's too brown. I think we should start again. It's already doing a superb job, but I would like it to go faster not quite such a deep cut. We'll change the speed to 400. Slightly less smoke because we'll be converting less solid into gas. So there's our first pass. We've already got some quite nice profile into it, and I'm just going to put a little mark on here because that's pass number 1. We have to do this multiple times. You can take a look in the middle here and you'll see there's a little white spot in the middle there where it hasn't cut. It's the same as the outside here. So that has basically, that's the mountain top where we've got, if you like, no cutting. That's 5% power, which is not having an effect at all. And this bit round the outside here is 100% power, which is digging away a lot deeper. So we just run the same program again and again and again to get deeper and deeper and deeper, because whatever shape we've got there, proportionately the same percentage will come off every time. So the more that came off this time, the more will come off next time. And so the profile will gradually get more 3D as we take passes. Okay, well, we're going to run the 4th cut and you can see it from the front. With all its information. Looking at it front on, you can't really see how 3D it is. When we look at it from the side, look at that. It's quite incredible the definition that you're getting on these features in the middle here. Well, we did anticipate that this was going to be one of the machine's strengths, because you only have to look at a company called Kearns, and they specialise in this sort of stuff using RF lasers. So, you know, I knew that it was going to be good, but I have to say that's exceeded my expectations. Took a little bit longer than I thought, but on the other hand, it's still not too bad for 30 watts. We found a way of balancing the speed, the material extraction, and the least amount of damage. It's a pale brown, it's not burnt, it's not barbecued. I'm very happy with the result, and the crispness and the quality of it is superb. There's no hint of curtains on there at all, or those funny lines that I had previously on my other machine. That only took about 3.5 minutes for a pass, and there was 4 of those, so that's what, 12, 13 minutes. I suppose that's not bad. It's nice to find something really positive about this machine, even though it is rather niche. Well, I think that basically concludes our first very quick preview, if you like, of what this machine's capabilities are. I think what we're going to do now is gradually go back to the beginning, start looking in much more detail at things like photo engraving and ordinary engraving on different materials to see what the problems are. And I suspect that for that quality of work, on this price of machine, Kearns can't get anywhere near it. The only thing that limits us really is 30 watts. With 60 watts, we'd have been able to run twice as fast. We'd probably been able to run at 1,000 millimeters a second. Thank you very much for your time and patience again, and I hope this has been an interesting session. It certainly has been for me. And I'll catch up with you in the next session. Bye now.